Hello, I will show you how to control your MK1 robot with your Xbox controller. We're using here for a Raspberry Pi and the adafruit module to control the servos on the robot. The design of the robot is made by Mr. Carlos Franciscone from EasyBot. I will put a link in the description below. How does it work? With the controller you can move the base to the left and right by this joystick. To the left, to the right. I call this base the base. With this up and down movement you can control arm 1 up, down. Arm 2 you can control with this joypad with down, up. The gripper is controlled by the buttons, like X is open and B is closed. You can also use the controls simultaneously, so it will move up and down and left and right at the same time. You can also open the gripper during the process, whatever you like. In this video I'm going to show you how everything is set up. I will make it short and brief and the most easiest way I could think about. This is the way how I connect everything. The pictures you see here, I didn't draw them myself. I get them from the community and they're open source so everyone can use them. The only thing I did is place the lines in between them. What I did is first you're going to connect pin 1, that's the default from the Raspberry Pi, to the VCC of the adafruit module. Then you're going to connect pin number 3, that is the SDA bus connection, to the SDA connection on the adafruit. Then you're going to the SCL connection, that's pin number 5, and you're going to connect it to the SCL on your adafruit module. Then you're going to connect the ground. The ground is pin number 6 on the Raspberry Pi, and you're going to connect it to the ground pin on the adafruit module. After that, you can connect your servo motors. Channel number 0 I use to connect the base motor. Channel number 1 I connect the motor of arm 1. Channel number 2 arm 2. Channel number 3 the servo gripper motor. After that you need to supply power to the screw terminals. You can use any power supply you like, but it's gotta be 5 volt DC. So you can use batteries, adapter or something else you have. The first thing I did is I installed the latest version of Raspberry from the Raspberry Pi Foundation website. I will put a link in the description. I put it on the micro SD card and I put it in my Raspberry. The only thing I did until now is I have enabled the FNC connection so we can see what I'm doing, so I can record this. The first thing we want is that the Raspberry can communicate to the adafruit, the PCA9685 module, the servo drive module. And what you need to do for it is to go to Preference, Raspberry Pi configuration, and go to the interface, and the I2C bus connection we need to enable, like this. Okay. Now we've done this, we can check if the bus is working correct. You can go to the terminal and you can enter sudo I2C detect -I -1, also I1. It looks like this. This is fine. Now it's working. These are the addresses on the bus and you can see nothing is connected at this moment. I will connect the adafruit module, and now we're going to run the command again. And you can see address 40 has arrived and address 70. So I know the wiring is okay and the adafruit module is communicating to my Raspberry Pi. We can close this window. And what we need to do now is, in order to make the adafruit work in our Python code, we need to import the library to do that. The easiest way I found out to import the library is to go to the menu, go to Programming, and go to Tony Python IDE. When you start it up the first time, you will get the layout like this, but we got to switch it to regular mode. The configuration has been updated. Restart Tony to start working in regular mode. Okay, so close it, restart it, and it's gonna look different now. It looks like this. We go to Tools, Manage Packages, and here you can type in the package you need, so the library we need, and you can search it. What you're going to type in here is adafruit PCA 9685. Find. He's going to find this one, the adafruit PCA 9685. This is the version I use, and you just install. You will see that it's standing right here, so everything is okay. You can close this now. This is the code I use to control the robot arm. The first thing we are going to do is to import some libraries to make the code work. First you import the time library. That's a standard library. Then we're going to import the adafruit library. This is not a standard library, so you got to install it. Earlier in the video I showed you how to do it. Then we import the sub process. That's also a standard library. Then we import the Pygame. That's also a standard library. The sub process we use to clear out the terminal window when our code is running. Otherwise the screen will fill up with all the positions the servo drives are going to. So it's easier to see which position you are in. The Pygame we import to use the joystick functions. Later on I will show you how to define the joystick or gamepad or Xbox controller or whatever kind of controller you like. It works for now everything I tried it always worked with. So it's a universal library. Here are some settings to control the adafruit servo drive module. This line of code sets the address. If we don't fill here, if you leave this empty, it will go to address 40, the default address, and that's the one we are using right now because we got only one module connected to the I2C bus. So you can leave it like that. This one is to make a frequency from 60 Hertz. We use it to control the pulses to the servo so they can make their movements. Here we define some variables and set the start positions. Arm 1 is 400, arm 2 400, base is 400, and the gripper is 450. These numbers they correspond with almost the neutral position of the arm, the neutral position of arm 1, the neutral position of arm 2, the neutral of the base, and the gripper. This stop I use to stop the while loop. It's connected to a button on the Xbox controller, but I will show you later on. This line of code, this will set the start positions of the servos. What will happen here is that the numbers are standing here. They will get loaded to the arm 1 will get loaded to arm 1, so it will put arm 1 at position 400, and that's a neutral position. Just when you start the program the first time, your robot will move abrupt to these positions, so that you know that if your robot is moving from when you start up, that's the reason why. Here we do the pie game in it. After that we say joy1. That's the name of the controller. This name I made up. You can pick whatever name you like here, but I like to use short names because this name is going to be used a lot down here. So everywhere joy1 is standing, if you made a different name here, so if you made a longer name like my first Xbox controller or something, everywhere joy1 is standing, there would be standing my first Xbox controller, and it makes it harder to read because you get a lot of text with not much extra information. So I leave the name short, but you can change it in whatever you like, but then you gotta change it everywhere in the code down below. Here we start the while loop, and the while loop is stopped with the stop variable, and that variable is connected to the button A on the Xbox controller. To give you a little bit more information about how the Xbox controller is working with our code, I made this little drawing, and I will, so you can see which axis is connected to which joystick and how the buttons are connected to our code. This is the type of controller I'm using. So I have a joystick here, and that's in the drawing this one. When the joysticks are not touched, they will generate a value 0. If you start touching the joystick and pushing it up, the value will increase from, in this case will decrease from 0 to -1. If you are pressing it half the way up, you will get -0.5. If you're pressing it 3/4 up, you will get -0.75. And the same is happening when you push it down. You get a value, a positive value from 0 to 1. So if you push it halfway down, you get 0.5. If you push it 3/4 down, you get 0.75. This is axis 1 is for the up and down movement. Then you can push the joystick to the left and to the right. It's the same principle, only a different axis. The same with this joystick. It's the same principle, but only the axis numbers are different. Then you're going to get the keys you want to use. When you press the I key, joy.get button 1 will be generate a value 1. Excuse me, this is value 3. So if you press the Y button, joy1.get underscore button 3 will be a 1. If you release it, it will be 0. The bumpers in my case are also analog values, so it works a little bit like the joysticks. When they are in resting position, so when they're not pressed, they are -1, and when you start pressing them, the value will decrease until you press it all the way and it will be 1. The left, I don't know if it's a bumper or button, but the left button is a digital value, so it will be 0 or 1. So when you press it, it will be 1, and when you release it, it will be 0. From here, we're going to define our controller, in this case our Xbox controller, but you can also use other brands of controllers. The principle is the same, so I will show you how it works. From this line of code, you're going to say how many buttons your controller has. If you have only one button, you fill in get button 0, because you start counting from 0. If you have 2 buttons, you're going to also get button 1, and so on, and so on, and so on. If you don't know for sure how many buttons you got, and sometimes with the new controls it's a little bit tricky, because some of the bumpers, they are not buttons, but they are axes. So the best way to do it is to, if you are guessing, guess on the low side. So if you think you got about 6 buttons, start with getting 4 in the first place. Because if you're going to say you have 6 buttons in the code, but the controller only has 4 buttons, your code will generate an error and will stop. So the easiest way to do it is to start then from, say, get 4 buttons and the code is still working, get 5 buttons, the code is still working, get 6 buttons and the code crashes. Then you know you only have 5 buttons. The same way with the axis. This I made a comment. You can remove the comment and then you will see on the terminal when your code is running which buttons you are pressing. But I leave it in comment for now. And the same with the axis. If you remove the comment, then you can see the position the axes are in. This is a clock tick. You can change it, but how lower you go, your robot arm will probably start to shake more. But you can mess around with it. You can put it up high. It does no harm. But you will see it gets less smooth to run everything. The sub-process call we call the clear call. The clear call is used to make the terminal screen empty after a line of code. So this is with the positions. When we will run the code, you will see that it only shows which position you're moving to and which position the servo is in. And then it removes the line. If you don't remove the line, you will get all the previous positions and the previous moves in your terminal screen. It will fill your terminal screen up. This piece of code is used to control the base. The first thing is we set a variable called base joy. Base joy is connected to the axis 0 on your Xbox controller, and the axis 0, that is the left side joystick, and when you move it to the left. When you move it to the left, it will generate a value smaller than minus 0.5. When that happens, the actual position called base will from that position will be subtracted as minus 5. When that happens, the servo will move minus 5 to the left, which will generate it's going to the left. This is used to print this text to the terminal screen, so you can see that it's going to the left, and this is used to print the actual position of the base to the screen. This will send the base position to the adafruit module. We will send it to the servo drive, so the servo motor will go to this position. To go to the right side, it works the opposite. So if base joy is bigger than 0.5, and that will happen when you move the joystick button of the joystick to the right, the base will get added 5, so the servo will move 5 positions, which will be going to the right with our robot. You're going to print it again, print the actual base position to the terminal screen, and send it to the adafruit so that the driver will control the motor. For controlling the arm, we use the same principle as the base, so I'm not going through this. Arm 2, it's the same principle as the base. The gripper is a little bit different because we're using the button here. Here you declare the button, gripper button open. It's connected to the button 2 on the Xbox controller. If you press button 2 on the Xbox controller, it's going to generate the value 1, and here you're going to compare it. So if the value is 1 of the gripper button open, the position will be printed to the screen, and here this text will be printed to the screen, so the grip position is opening. And here we add 10 pulses to the actual value the gripper is standing in. Here we send it to the adafruit module, so it will control the motor. The gripper closed, it works almost the same, only a different button, button 1. The compare is the same. If its button is pressed, it will go into this line of code. If the button is pressed, it will decrease minus 10 from the actual position it's standing in. It will print the position to the screen again, and it will print the text, the grip position closing. Here it will send it to the Adafruit. This is the last line. If you press the A button, you will generate the stop signal. It will set the stop signal to 0 because it's 1. And when that happens, the while loop will stop, and the finally command of the try loop will be executed, and that will be printing stop to the screen. And that's how all this code works. Okay, now we're going to try the code and see what happens. You can start it by pressing Ctrl T. It will open the terminal screen. The code is running right now. And when you start pressing buttons, I will press the joy 1 to the left side. You will see the base is going left. Press to the right, base is going right. Arm 1 up, arm 1 down, arm 2 up, arm 2 down. The gripper opening, gripper closing. The code I wrote is very simple, so it has no limits. So if you keep pressing the button, if you keep pressing the joy button to the left in example, it will start decreasing the value, but it will also go negative. It's not limited. You can make that, but I didn't do it because the code will get more complex and it's hard to see what's happening for if you're not good in coding. So I made it very simple. You can also move the buttons at the same time, so you will get more text and on the screen. When you want to stop the code, you can just press A, the A button, and it will stop running.